Please take out a pencil, your notebook, a closed Chrome book, and if you didn't pick up a handout, please quickly go get one. Turn off your phone or put it in airplane mode. If you're wearing a smartwatch, please turn the cellular data off. Put your phone in your backpack. I'm sorry I can't be here with you this morning, so I need you to watch this video to get the complete instructions. Please put your pencils down and keep your eyes on the screen. What do we know about minerals already? Maybe you've heard the term mineral. What do we use them for? Today we're going to explore minerals. We're also going to take a look at our phones. What do we really know about our smartphones? Your smartphone is full of minerals. More than half of your mobile components, including its electronics, battery, and speakers, are made from mined, semi-processed materials. Aluminum, titanium, potassium, silica, you've probably heard of these before. Copper, silicon, tantalite, bauxite, tin, lithium, manganese, nickel, graphite, cobalt, bastanite, sclerite. All of these can be found in our cell phones. Mobile phones and other high technology communication devices could not exist without mineral commodities. Over 60% of our world's population owns a cell phone. The first mobile device was released in 1983. More than half of all components in a cell phone, including its electronics, display, battery, speakers, and more, are made from mined and semi-processed mineral material. The demand for electronic devices puts pressure on metal and mineral supply chains and on planet Earth. Metals and minerals are natural products. They come from the earth and need to be mined and processed to be used. Let's take a look at this video and find out more about our smartphones.
As of 2018, there are around 2.5 billion smartphone users in the world. If we broke open all their newest phones, which are just a fraction of the total that have been built, and split them into their component parts, that would produce around 85,000 kilograms of gold, 875,000 of silver, and 40 million kilograms of copper. How did this precious cash get into our phones, and can we reclaim it? Gold, silver, and copper are actually just a few of the 70 or so chemical elements that make up the average smartphone. These can be divided into different groups, two of the most critical being rare earth elements and precious metals. Rare earths are a selection of 17 elements that are actually common in Earth's crust and are found in many areas across the world in low concentrations. These elements have a huge range of magnetic, phosphorescent, and conductive properties that make them crucial to modern technologies. In fact, of the 17 types of rare earth metals, phones and other electronics may contain up to 16. In smartphones, these create the screen and color display, aid conductivity, and produce the signature vibrations, amongst other things. And yet, crucial as they are, extracting these elements from the Earth is linked to some disturbing environmental impacts. Rare earth elements can often be found, but in many areas it's not economically feasible to extract them due to low concentrations. Much of the time, extracting them requires a method called open-pit mining that exposes vast areas of land. This form of mining destroys huge swaths of natural habitats and causes air and water pollution, threatening the health of nearby communities. Another group of ingredients in smartphones comes with similar environmental risks. These are metals such as copper, silver, palladium, aluminum, platinum, tungsten, tin, lead, and gold. We also mine magnesium, lithium, silica, and potassium to make phones, and all of it is associated with vast habitat destruction, as well as air and water pollution. Mining comes with worrying social problems too, like large-scale human and animal displacement to make way for industrial operations, and frequently, poor working conditions for laborers. Lastly, phone production also requires petroleum, one of the main drivers of climate change. That entwines our smartphones inextricably with this growing planetary conundrum. And what's more, the ingredients we mine to make our phones aren't infinite. One day, they'll simply run out, and we haven't yet discovered effective replacements for some. Despite this, the number of smartphones is on a steady increase. By 2019, it's predicted that there'll be close to 3 billion in use. This means that reclaiming the bounty within our phones is swiftly becoming a necessity. So, if you have an old phone, you may want to consider your options before throwing it away. To minimize waste, you could donate it to a charity for reuse, take it to an e-waste recycling facility, or look for a company that refurbishes old models. However, even recycling companies need our scrutiny. Just as the production of smartphones comes with social and environmental problems, dismantling them does too. E-waste is sometimes intentionally exported to countries where labor is cheap but working conditions are poor. Vast workforces, often made up of women and children, may be underpaid, lack the training to safely disassemble phones, and be exposed to elements like lead and mercury, which can permanently damage their nervous systems. Phone waste can also end up in huge dump sites, leaching toxic chemicals into the soil and water, mirroring the problems of the mines where the elements originated. A phone is much more than it appears to be on the surface. It's an assemblage of elements from multiple countries, linked to impacts that are unfolding on a global scale. So until someone invents a completely sustainable smartphone, we'll need to come to terms with how this technology affects widespread places and people. Want to learn more about the global impacts of everyday items? Check out our lesson on the life cycle of a t-shirt. And if you'd like to help us keep making lessons about important topics such as these, we invite you to make a small contribution on our Patreon page.
So even though that video was a few years old, it applies to us today. We today are going to look at what is in a cell phone and where do these minerals and elements come from, whether it be for the display, for the circuits, for the battery, for the speakers. There are many parts to your phone that you may not have realized. Here's our world map. We've looked at it a few times. We're looking at the mineral commodities produced and where they come from. So we can see from this map, there's only a few locations in the world where we get our minerals from. Looks like a lot of our minerals come from China, Peru, and Russia. Some of the minerals used to manufacture phones are from places called conflict minerals. They're mined in areas that are have fighting and armed illicit activity. And when we purchase these minerals from places such as this, we're funding rebel groups and contributing to political and economical instability. It may neglect workers' rights or violate safety standards. And we don't offer fair wages to these people doing this hard work. Countries and rebel groups that mine and sell conflict minerals have committed war crimes and human rights violations. So we're responsible for this. We need to recapture critical minerals and rare earth elements to reduce technology waste and lessen our need on these new sources to be mined. The U.S. is responsible for more e-waste or electronic waste from any other country. 350,000 cell phones are disposed of every day. That's 152 million a year. There are 7.2 billion active mobile devices in the U.S., larger than the U.S. population. Only 12.5% are recycled. 1 million recycled cell phones yield 35,270 pounds of copper, 772 pounds of silver, 75 pounds of gold, and 33 pounds of palladium. Okay, we have a worksheet in front of us. Let's put our name on our worksheet. Today's date is November 7th, and the period. Let's read the instructions together. Cell phones have mineral components that are from mining. The table below lists the many mineral resources needed to make cell phones and the percentage of the mineral resources imported by the United States and other sources. This table below, we're going to calculate the rank of importance and the percent self-sufficiency for each mineral. NA means not available, so we don't have much data for that. We'll just leave it out of any calculations. We're going to start with rank. Okay. We're going to fill in the column ranking the minerals from lowest to highest. So we look at the percent numbers, the third column. We can see that there's 2 with zeros already numbered for us. The US has lots of gold and lots of iron. So we import 0% gold and iron. So we're going to rank this number 1 from our lowest imported. Our next lowest is magnesium. It has a number 2. So we're also going to put a number 2 in that box. It's the second lowest. So the United States has plenty of magnesium. What mineral is next? Take a look at our numbers and find the next highest. Remember, Na is not applicable, and we're not going to worry about that one. Put your finger on the next lowest. If your finger's on beryllium, you were right. You will then continue. Now remember, some share the same rank, just like number 1. Now let's take a look at the other column. Pardon the bell. We're going to figure out the percent self-sufficiency. What percent we rely on other countries. If we import 87% of antimony, then we need 13% of our antimony from other countries to make cell phones. So we have 87% of what we need. We're importing 13%. Take your net percent imported, minus it from 100 to get your percent imported. You can easily calculate this with simple math. I've done the first 4 for you. You need to continue with the rest. This is quick math and should only take you about 5 minutes or so. The research component, you're going to pick 3 from the minerals above or using the links to find out more information about minerals. For instance, if you want to know how gold is used in cell phones, you can check one of the links posted in Google Classroom and find out more. Then you need to find where it is found on Earth. There are 3 websites for you to use. We've got this one here from the Natural History Museum. We have this one here from the United States Geological Society. We have one here that talks about all the, quite a few, 10 different minerals from MEC. I'm not sure what that one is. And another one here with that infographics we saw earlier if you want to dive deeper into that. Once you've finished with this one, you're going to use the table from the front to answer the 6 questions on the back. I'm not interested in having you Google these questions and answer them. I want you to actually look at the data and come up with some answers on your own. This is due on Wednesday, and you have this entire class period to work on it. Does the United States have resources to make cell phones without using any mineral? Please make a complete statement answering your question. Gold is important to conduct electricity in the cell phones and computer circuit boards. What countries are major sources for gold? If you were going to be a gold miner, where would you go and why? What's the fewest number of countries needed to get the mineral resources to make a cell phone? List the countries. List the mineral resources in a cell phone that the United States would get solely from domestic source. Describe other uses you know for some of the minerals in a cell phone, and explain why mining is important to you in your daily life. Oop, this page is wrong. It's not due tomorrow, it's due Wednesday. All right, you have the rest of the classroom to work on this. You also have the rest of the weekend. We'll see you on Wednesday.